Hello friends, welcome back to our YouTube channel Networkforyou. We welcome you all in our YouTube channel Networkforyou. Today we are going to discuss something about OSPF and we are going to do some lab in EVNG. As per our student request, we are doing this live session. In this session we are going to discuss about OSPF theory as well as OSPF lab. Basic theory and basic OSPF lab. So let's start. I already opened the EVNG. I hope you have already. If you don't know EVNG, you can watch our playlist EVNG for beginners, so you will learn that one. Okay, and this video also after live it is available in our EVNG. So what we will do here, I created one folder. I will go inside this folder. Let me create new lab. I will write lab name. Whatever name we need to give, we can give any name. I will write OSPF lab 1. Okay. Anything we can give, no issue, excuse me. So I will write OSPF lab 1. I will press save. So this is our dashboard. In this dashboard we can take the like router, switches. Already we know that one, but if you don't know, no issue. We are going to show you how we can take router, how we can connect the router, each and everything we are going to discuss here. But before going to that one, we are going to discuss some theory about OSPF and then we are going to continue the lab. So let me write some points also. As soon as I discuss, it is better, so you will have the idea about that one also. So today our session for OSPF. So let me write here OSPF and the full form of OSPF, then basic points. So you should remember this one. In interview they are going to ask these types of question also regarding the OSPF. So let me take pen tool here and do this one. If you see here OSPF, let me write here OSPF. OSPF stands for, you need to remember OSPF stands for Open Shortest Path First. Okay, so I will write here Open Shortest Path First. Shortest Path First. This is a full form of OSPF. OSPF is a routing protocol. This is a very good protocol. We use this one. In this routing protocol we can connect unlimited routers. So for that purpose many organization is using OSPF because it is a open standard. Like no need to have only CISCO devices. Even if we have Juniper or other vendors, we can run the OSPF. Like EIGRP, before it is CISCO proprietary, but now they change. It is EIGRP also for open standard. But before EIGRP is for CISCO only, but now they open. So anyhow, second point we will write. First point I will write here. First point, it is standard protocol. Standard protocol. Standard means it can work in any device. Okay, not only CISCO or not only Juniper, every vendor. So I will write open standard. Okay. First point, it is a open standard. Second point, we can say it is link state protocol. It is link state protocol. Like we have interface, all interface are connected to links. So that's why we are saying it is link state protocol. We have our friend Kanu Samir given as a command. Nice. Thank you very much. So let's continue. It is a link state routing protocol. So let me write it is a link state routing protocol. We are going to discuss when we are going to do lab, that time we will discuss what is link, that one also. Link state protocol. So when any link is go down, any interface go down, they will send the updates like that. Okay, and it is use shortest path algorithm, SPF algorithm. So algorithm is nothing but, just remember there is a technique or formula the router use. When we configure the OSPF in the router is using some type of formula or a technique or algorithm to calculate the best path in the routing in the route. Wherever we have routing table, we already know that one router is having the routing table. In routing table, router will store the best path for all the network, whatever network he know. Okay, so for that purpose OSPF is using the shortest path first algorithm. So this is also important, and this is interview question. So we can write OSPF use SPF algorithm. You need to remember this one, SPF algorithm, or let me write also here. Let me write here what is the full form of SPF, because in interview they will ask these types of question also. SPF, that is S stands for shortest path first. Okay, shortest path first algorithm. So OSPF use the SPF algorithm. So let me write algorithm. You can write down this one if you want to write, or anyhow this video will be available in YouTube even after live session is finished. So if you want to write that time also you can write, no issue. So other point, as I told you, we can connect unlimited of routers. So router is nothing but we are saying hop count. So we can write unlimited hop count. Okay, in OSPF we can connect unlimited hop count, but Cisco recommend 40 to 50 router in one area. Let me write here, but if you Google it, you will get this information also, like Cisco recommend 40 to 50 router in each area. So let me write that one also. This is also important point, but Cisco recommend. This is for knowledge purpose, or you can if you want, but this is important. Cisco say 40 to 50 in each area. If you Google, you will get this information also, each area, because we have area concept in OSPF. We are going to discuss that one also. To reduce the LSA flooding, we are using the area concept in OSPF. We are going to see that one also. And in OSPF we have metric to calculate the routes. We are using matrix. That matrix is nothing but cost in OSPF. Same like in RIP we have, and EIGRP also we have. So here we have matrix. So I will write matrix is cost. In OSPF matrix we are going to see in our lab. I am going to do the lab. We are going to see that one. So there is a standard value from the Cisco routers, 10 power 8 divided by interface bandwidth. This is a formula we are going to calculate also. Remember, Cisco give us one formula to calculate the matrix for the OSPF in the Cisco device. 10 power 8 divided by bandwidth, interface bandwidth. Which interface we are calculating, that interface bandwidth. Okay, and 6 point we can write here. AD value between the AD value. AD stands for administrative distance between the routers. So let me write AD value is 110 for the OSPF. 110. We are going to verify the AD value also in lab when we do the lab. Administrative distance value is 110 in OSPF. AD value, that is known as AD value. AD value is nothing but a trusted path between the shortest path. Whatever the value is low, we will treat that one as the best. Example, if you configure two routing protocol, which is going to become which is going to be prefer, which example I configure OSPF. Example, let me draw here. I have one router here, I have another router here, I have this link here, I have another link here for the same source. Example, this is 2.2.2, and this one I have the AD value 110, and this one is I have 150. So this will not prefer, this will not be present in the routing table, but when this interface go down or this link go down, this value is going to be this link information is going to be present in the routing table. So we are going to see that one slowly, no issue. Okay, no doubts, right? If anyone is having any confusion, they can ask me. This is a basic theory I am writing just to brush up everyone. After that we can do the lab in EVNG. Okay, so I wrote the AD value is in OSPF AD value is 110, and we can say it support only equal cost load balancing. It support, like EIGRP is supporting equal as well as unequal, but here OSPF is supporting only equal cost load balancing. Equal cost load balancing, important point for interview purpose also. OSPF, let me write here, OSPF, yeah, no problem. Let me read comments. We have one comments here. Go brief about the cost. Yeah, no problem. We are going to do the cost. I am going to do lab and I am going to show you that one. Cost for the different interface is having different cost value. Like if you see, Ethernet is having different costs, as well as if you go for fast Ethernet we have different costs, and if you go for gigabytes Ethernet we have different costs. We are going to see that one, no issue. Okay, let me give high level, then I will do a small lab. After that we are going to do that one also. Okay, so let me go for the point number 7. Point number 7, what I am saying, it support only equal cost load balancing. OSPF support only equal cost load balancing, whereas if you remember EIGRP support equal as well as unequal, but here OSPF only the equal cost. Now we will go for point number 8. It support VLSM, that means it support subnetting, whereas if you remember in the RIP did not support the VLSM. Subnetting we cannot do. If we are using RIP will not support the subnetting. So whenever you are using the RIP routing protocol, you need to remember RIP will not support the subnetting, but OSPF is supporting the subnetting. This is also very important point. It support VLSM, variables length subnet mask, and CIDR. Okay, CIDR. Now we will go for the 9 point number 9. It in the OSPF area concept is introduced. So let me write, in OSPF area concept is introduced to reduce the LSA flooding. Area concept introduced to reduce LSA flooding. LSA flooding. LSA flooding means the link information is flooding in one area to other area. Example, if we have like different department, IT department is separate. Just I am giving as a example. If we have IT department, we have like another department, sales department, and like HR department. All department managers are separate. If they have any issue, they will go to that manager, and that manager will listen to them, and they will send the information to other. It is not like if we have any issue in any department, it will go mixed with everything. Not like that. Anyhow, what I want to say you that we have area concept in the OSPF. So let me show you also. I have router here. Example, this is the area 0 router. I have another router R2. This is area. This one area 1. If this link go down like this, and this one more router, this is in area 0 again. If this link is go down, then this router will send the information. I lost the area, information about this area, example 1.1.1. This router is going to send the LSA to other routers asking the I don't have the information about this network. Do you have the information about this network? So this will go in the same area. If you have area 0 only, it will flood in the all area. But if this is only area 0 is example only here, so it will flood to only this. It will not go to other network. Okay. LSA flooding we are saying. We are going to see later that in detail also. Just now remember in OSPF we use the LSA flooding. We use the area concept to reduce the LSA flooding. Okay. In OSPF we use the area concept to reduce the LSA flooding. Okay. So let me check again. We have one more comments. Your handwriting is too nice. Thank you very much. We will try to cover more topics. Thank you. So now next point we will go. Area concept already we discussed, and area 0 is also a backbone area. Let me write here area 0. Area 0 is backbone area. Area 0 is backbone area. Okay. Area 0 is backbone area. Whenever we are running the OSPF, we should have area 0. Okay. Without area 0, we cannot connect the multiple area. So we need to remember all the area must connect to area 0. Let me write another point here. All the area should connect to area 0. All the area should connect to area 0. Area 0 we should have, in else we cannot connect the other area to other area. If we want to connect the one area to another area, we need to have the area 0, and area 0 is known as backbone area. Any confusion? This is basic theory. Okay, no issue, right? So we can say it support the authentication, like password also we can put here. So we can say OSPF support authentication also. OSPF support authentication. Okay, OSPF support authentication. Whatever password you need to keep, you can keep that one also. And updates are sent to the multicast IP address. Updates are sent here. The link state updates is going to be sent to the multicast address. Let me write the address. This is also in interview question. Multicast address 224.0.0.5. Okay, so this is a multicast address. Updates are sent through a multicast address 224.0.0.5. and let me write one more point, 14 point. Hello packets every 10 seconds. We have hello concept in the OSPF. If we connect to router, they are sending hello to each other. So like we need to remember the time, hello timer and that time. Like let me write here, OSPF one router is going to send the hello packet to other router in hello packet time is 10 second. Okay, every 10 second they are sending the hello packet, and we have that timer is 40 second. We are going to verify, we are going to check in the lab. And router let me write here 15 point. Router send the link state. Like if you remember in OSPF in RIP every time we are sending all the information, whereas in OSPF we are not sending all the information. We are sending only the update information. Like we can say router send only the changes in the updates, not the entire routing table in the periodic updates. What I want to say that router send only, let me write here, router send only changes. Only changes, like any interface go down or any new interface is come up or any new interface is configured as OSPF, that only it is going to send in OSPF. Okay, not the entire routing table. Not the entire routing table. Whereas in RIP we are sending entire routing table, whereas in the routing this OSPF we are not sending entire routing table. Whatever information, whatever updates we have, we are sending that updates only. These are the some points I wrote. If you have any more, we can write that one also, but these are the more important points. We have more points like ABR, ASBR, Later we are going to discuss that one. Yeah, okay, about the area border router. And so we have the, someone write, let me read the comment. Multicast is very simple example, please. See, multicast, like whenever routers are talking to each other, they will send to information in like one IP address. That IP address is multicast. If you want simple example for multicast, like if you remember, we have unicast. Let me write here unicast. Unicast means 1-to-1 is known as unicast. Then we have multicast. Multicast means the guy who is interested, he is only going to receive that information, not all the guys. That is multicast. And third one is broadcast. Broadcast means even if you are interested or not interested, you will get the information. This is the example for the unicast, multicast, broadcast. Unicast means 1-to-1. Multicast means 1-to-many, but whoever is interested, he will receive. Example, this is a live session, we are discussing. Whoever is interested, they join. That is a multicast. And if any broadcast means even if you are not interested, you will get that information. That is broadcast. Okay. So now I will erase this one. If you want to write down, you can write down this one, or if you want to see this one later, you can see later. Now I am going to erase this one. Okay. So we can do some more discussion and then we can do the lab. Anyone is having any questions, they can ask me. I will erase this. Okay. So now we are going for the some lab. Before lab, we will discuss some packets. We have OSPF packet types. OSPF packet type. OSPF packets type. We have hello packet, that is type 1. Type 1 is hello packet. To discover neighbor, we use hello to discover neighbor. Used to discover neighbor. Like when we connect to router, discover neighbor. Let me write here, then I will tell you. Okay. Like if I connect this router and I connect another router, these are the two router, and we configure the IP address, then we configure the OSPF. Then this router will send the hello message, hello packet, and then this router will also send the hello packet to discover the neighbor. And then we have the DBD, database description. Database description, that is a type 2. We have type 2 DBD, database description, database DB, database description, DBD. This one is used to, what we can say, synchronize between the router. This one is used to get the synchronization between the two router. Like let me write sync between router. Okay. This one is used to get the sync between two router. Then we have the type 3. Type 3 link state requests. We have link state request. Okay. What we can say here, list of all missing LSA. Whatever information is missing, like list of all missing LSA, link state, whatever is missing, we will discover here that one. And then we have type 4 packet, that is link state update. Here they are requesting in this type 3 whatever is information. Example, this is a router R1, this is a router R2. First they send hello packet, and they the other guy also reply hello packets. They discover the neighbor, they become the neighbor. Then they synchronize the DBD, the database, high level information they discover, they synchronize. Then they check and they told, I don't have the example. I have here network 1.1.1.1. Here example I have 2.2.2.2. So this guy is saying, R2 guy is saying, this one is not present. Example, R2 guy is saying this is this information I don't have 1.1.1. So can you send me? He sent this one here. So in R4, link state update will send, like link state, whatever is missing the other guy will send, and whatever is in the updates, okay, whatever is missing he will respond. We can say here respond to LSA, okay, respond to LSA. We can write respond to LSA. So here type 4, and then type 5 we will acknowledge, yes, I receive what information is missing from me, you give me that information and it is I receive that one, thank you, like that. So link state acknowledgement, we can say link state acknowledge, ACK I will write in shortcut, okay, acknowledgement, acknowledge the reception of the LSA, we can say something, acknowledge that saying that I receive that one. So we have type 1. In type 1 we are discovering the neighbor by saying the hello. In the type 2 we are discussing the high level database DBD, and we are synchronizing the database between the router. And we have type 3. In type 3 we are requesting whatever is information is missing, and type 4 we are responding to that request, and in type 5 we are saying yes, I received that information, thank you, like that. Okay, any confusion, any doubts? Nothing, right? So I will erase this one. Now we will go for the router ID also. Already we discussed the router ID, but anyhow router ID. Each and every router is having one ID that is in the form of IP address, that is a router ID. Like example, if we configure the SSH or telnet on the router, we can remotely access with the help of router ID also. And every router should have the router ID. We should have the router ID, okay. So what I will say here in simple words, router ID, the highest IP address of the active interface of the router is a router ID. We have two types here. Let me give you example. I have physical interface F0 by 0. I have physical interface F0 by 0, F0 by 1. I have logical interface. This is a loop back. Okay, this is a loop back. Example, I am saying loop back is nothing but a logical interface which is never go down. Just remember, loop back is an interface, logical interface which will never go down. So if I assign the IP address here 192.168.1.1 here, and here is 10.1.1.1, and here if I assign 1.1.1, then which one is selected as a router ID? We can say like this, router ID. So first point you need to remember, the loopback interface is prefer first of all. So whatever the highest value of the highest IP address of the loopback, that is going to be prefer. So if I have two loopback, example, if I have loopback like loopback interface here 100.1.1.1, so this will be prefer. Okay, if I don't have this one, this will be prefer. If I don't have this one, then physical interface, whatever interface I have with the highest value, this is the highest, so this will select as a loopback, this will select as a router ID. If I don't have this one select as a router ID. Or manually also we can assign the router ID, like router ID and like this, and we can assign also, like example, if I want to assign, I can assign manually also in our router. So what you need to remember, router ID is nothing but a IP address. It is in the form of IP address. By default, router is taking the router ID as a logical interface, highest IP address of the logical interface. If we don't have logical interface, then it will go for the physical interface, highest IP address of the physical interface. Okay, so this is a router ID. Now let me go. Let's start some lab, so you will have the idea, else we will have all theory classes. So we will do one lab, then we will look for the cause also. Okay, so this is a GNS3. If you want to add the node, we can go, sorry, this is EVNG, not GNS3, this is a EVNG. Here we are going to do a small lab. What I will do here, I will click this one and I will Ethernet one side. This is a fast Ethernet F0 by 0. Here is fast Ethernet. Here is the only Ethernet. So let me take one more router, because if we have one more we can make some cost difference also. So this one is the another router, so let me take R, and here let me take interface fast Ethernet as well as the Ethernet also. So what else we need? I will go here, I will save this one, another router. Let me move this hole here, let me move here. I hope you can see my screen, right? No issue, right? Someone write me comment, let me check what kind of routing router imagine to be used in EVNG for OSPF. You can use, no problem. I have this one. Some router is not supporting, but it is not particularly you need to use this one. Depending upon your RAM speed you can take. Let me show you here. See, we can do the routing protocol in this one or in this one or in this one also, because if you select this one, it is taking only 96 RAM, not GBs like 1 GB 2 GB. But if you see other router, we have I have some router also who is taking 4 GB of RAM also. Depending upon your PC CSR router, this router need 4 GB RAM. This router need 4 GB RAM to make the to run this one. If you see 3074 RAM, so any router you can take, no issue. If we, because this is only simulator, not real scenario, but you can take the, depending upon your system configuration, like if you have 16 GB RAM, then you can take the highest configuration RAM router. Okay, so here I will connect the fast Ethernet 0/0 to here also fast Ethernet 1/0. Okay, this here, if you see here I have fast Ethernet here fast Ethernet here, fast Ethernet here, normal Ethernet. So what I will do, let me give some label here, so we will have the idea also. So if I want to add any label, I will go here in the text and I will change the color here. Let me take any color, let me take this blue, and I will write here, just I want to assign the IP address. I will write 1.1.1.1 and /8, this one. Okay, so this one is here. Let me make this little bigger. This is little bigger, and let me make duplicate of this one here. I will have one more also. Let me take here, I will change here, no problem. Let me edit this. If you see here what I want to write, this is a router R3 and this is R1, this is R2. Let me write, first of all let me correct the IP router name also. Let me write 192. Let me go here in the edit. Let me move here 19, or first of all let me change this name, edit here. Here I will write this is a router R1, it will not take, yeah, this one is router R1. This one I will change to router R2. This is router R2. Okay, and here now I will go for router R3. Here I will go for router R3. This is router R3. So now I have 3 router. Let me write here. If I go here in this one or delete this, we will copy this one. Okay, so let me copy this, duplicate this, and I will go here. Let me go here and change the IP address. I will write IP here is, this one is router R1 and R2. If any IP, no issue, like we need to give this IP or that IP, we can give any IP. So what IP I will give here, I will give the here IP address 192.168 like that, and in between 1 means 1 and 2 means 12 I will give. So let me, again I lost this one. Okay, let me write here. I will write here 192.168.12.0/24. Okay, so this is the IP address in between this router. So this router will be 192.168.12.1 and this will be 12.2, and here we will have 23.1 and 23.2. so let me copy this one, duplicate this one, and I will move this here. Let me edit this one here also. Instead of 12 we will write here 23. Okay, any confusion? Nothing, right? This one and this one. If you are facing any issue, you can write in the comments. No issue, we will try to explain you again. We have like this, and this is a logical interface loop 0 we can say, and this is a loop. This one I will change to 2. Okay, 2.2.2 like that. Let me erase this. 2.2.2.2. So here I have loopback interface 2.2.2. Here I have loopback interface 1.1.1. Okay. So now we are going to write the configuration. So let me open the notepad. Any notepad. In the notepad we are going to write the configuration. So here, first of all, I am writing the configuration for the router R1. Okay, first of all we are assigning the IP address to the router interface. I will write and config t host name. Let me write host name R1. Let me write host name R1, and then we will write interface. We will check which interface we have here. F0 by 0. Okay, so I will write interface F0 by 0. IP address. What IP address? 192.168.12.1 space 255.255.255.0 and no shut. Okay, this is correct, right? Any confusion? You have any confusion? Nothing. I will copy this one, same thing, and I will paste here, and instead of here I wrote 192. So let me write 192, and in this place we are going to write 1.1.1.1, and here 255.255.255, not 255, this is /8. So 255.0.0.0 no shut, and this interface is loopback 0. So I will write interface LO loop 0. Okay, so interface loop 0, interface loopback 0, IP address this one. So this is a configuration for the router 1. This is basic configuration, only I assign the IP address. Okay, so now I will copy this one whole thing and I will paste here for other router also. Here this is the router 2, and in this one we have, this is the router 2, so we have this interface is F1 by 0. So I will change this one as F1 by 0 here, F1 by 0, and we have IP address 192.168.12.2. So I will make this 12.2, and if you see this one F0 by 0, so I will change here as a F0 by 0, F0 by 0, and what I have here 192.168.23. This one. So let me copy this and paste here, and then we will change. Okay, so I will go here 192.168.23 here, 23 here, 23.1, and again remaining same thing. Okay, this is a IP address how I assigned for the router R2. Any doubts, any confusion? Nothing, right? So 192.168.23.1, and this one is okay. So this router IP address finish. Now we will go for the R3. So let me divide here also, so you will have the idea. This page here like this, and here like this, and let me copy this whole thing and paste here. So we will change only the router name. This is the R3, and here 192. Here instead of this one remove. No need for this one. I think this one I remove. If you see interface, we have Ethernet E. So I will write E2/0 instead of here Ethernet. Here fast Ethernet. Here only Ethernet. 192.168.23.2. This one. This all are okay. So this is IP address basic what we are done from long time. Same thing. Now I will go inside the router and paste this IP address, so we will have the IP. So let me select this all device and power on this device. Select all, so all devices will be power on, and now I will select this all and I will double click this one, so it will open the CRCT or PuTTY software to do the configuration. We will open the console. It will take some time to open the console. If you see here R1 is open here 2 times. Let me close 1 time, and this is R2, R1, R2. It is opening. R1 is open already, R2 is open already. Now we are waiting for R3 also. Let's see, R3 will also come, or let me click here. R3 also came here. R1, R2, R3. Okay, this is the router. So here we are going to paste the configuration. Okay, so this is a R1. This one is R1. So I will go for this notepad. I will select this one, this configuration. This is for R1. How we know this is R1? We wrote host name as R1, this one. So I will go here, I will paste. So if you see no error, nothing, so everything is okay. Then I will go for the router 2. Here this one, I will go for this one. I will copy this one and I will go for the R2. I will press this one. Then here I will paste the configuration, so no issue. And then again here we can go for the R3, and here I will go to this one. I will write here no and then enter. Let me wait. This router is still not started. It will take some time. Now it is started. Yes. So now I will paste the configuration here also. So this one is done. So with this one we assign the interface IP to the all interface. If you want to check, we can check also. How we will check? We can write show IP interface brief. So we have here IP address we assign to this interface, fast Ethernet 0/0. No, not this one, here this one. Ethernet 2 0 by this one. Okay, 192.168.23.2, and we forget to assign this one. We need to create this one also. So let me write here interface loopback 0 or any loopback IP address 2.2. Let me write here 2.2.2, then space 255.0.0.0. No need to write no short, but if you want we can write, but logical interface always automatically up. So this one I will copy, I will paste in the router 2 also. 3, this is a router 3. So let me go in the configuration mode and paste the configuration here. Okay, so I will paste this one. So now this one is okay, we assign this one also. Now we are going to do the routing the OSPF configuration. So what I will do, whenever we want to do OSPF, we will write router OSPF 1. Then we will go, we are doing by interface method. We have two methods. We can do by network, like network ID way, or we can go for the interface method. So I am doing for interface method. Okay, we are doing for interface method because already it is 43 minutes continuously we are doing live. So I will do interface method. If we go for network method, it will take long time. So that one we can do in our next live session. In this session, I will go for this interface method and we will save this lab. And tomorrow we are going to come again live and we are going to discuss whatever is remaining in this one. Okay. So now what I will do, let me do the OSPF here. So here we will write interface. What interface I have here? If I want to do in the R1, you can see this interface. So I will copy this interface router here. Then I will go in that interface. Then I will write IP OSPF 1 area 0. I am doing for area 0. Okay, I am doing this for area 0. Let me copy this and again I will paste this one. Other interface what I have loopback. So interface loopback 0. So I need to put loopback 0. So I put loopback 0 interface. We need to go to that interface and then we need to write IP OSPF 1 area 0. And if you want to define the router ID, we can define here. We are not defining the router ID now because automatically router is going to take that router ID. Okay. So this is the two interface I have, that is F0/0 and loopback 0. I assign that one in the OSPF. So this one is done. So I can copy, I can paste in the second router also. If you see here, I paste here router OSPF and here we have F0/0 and another is F. Let me write this one F1 by 0, right? F1/0 interface. We need to, let me repeat again. See here, first we need, we are doing OSPF by using interface method. Okay. In real scenario, in organization, we are following this method. OSPF, whenever we are configuring, we are using this method, like interface method only we are using. Okay. And it is simple and easy. Just you need to write router OSPF 1, then interface, whatever the interface, that one, and then IP OSPF you are using process ID 1, you will write an area, which area you are using, that area. So here we have to interface F1 by 0, this one, and same thing here 0 by 0, this one is also finished. Now what I will do, I will copy this thing again, and I will go to the third router, this router, I will paste here. Here I have the, which interface I have, E. So here I will change this one, E2 by 0, this one E2 by 0, and here other one is a loopback 0 I use. So this one is okay. Any confusion for this OSPF configuration? Nothing, right? So now we will copy and paste. So from here to here, this is a OSPF configuration. Let me copy this one. This is for router R1. So I will go in the router R1 and let me press here, and I will paste this one. If I paste, no error, nothing. So it is correct. Okay. Now I will go to the router R2. This is the router R2. Here I will copy this one. This is the router R2. I will go in the router R2, and here I will press this one, and I will paste the configuration. I have some, I give the gap, that's why. So let me go here and remove this space and copy again, and then we will paste again. Okay. So let me go here and here also this one. Okay. Yeah, no issue here. We paste from here. So this is router 2. So now I will go for router 3, and in the router 3 I will copy from here to here, and I will paste this one also. So I will copy this one, I will paste here also this one. If I paste, any error, nothing, right? No error, nothing. And if we go here, we can check, we will get the notification, the neighbor form, adjacency, like that. We will see that one. Let me write here, show IP routes. Still we did not get the OSPF route. It will take some time. OSPF route is indicated by O, this one, like this. Still we don't have here. If you see here, we in OSPF we have status, loading, full, like that. Here if you see adjacency form, and here we have the process 1, and we have from the loading to the full. So now we have the OSPF route. If you see this route, I am getting from the OSPF 192.168.23.0. and what else? We done configuration for this one, and let me go to the router 2 also and check that one also. Show IP route. Here I have the OSPF route. I have this one. This is the 111 I am getting from the OSPF, and this 222 I am also getting from the OSPF. This one I am getting two routes. One is this router. I am talking about this router. I am getting this route 1.1.1.1, from which interface I am getting this one 12.1. So this one is saying I am getting the information about this one from this. So this is okay. Another is getting from the 2.2.2, this one from this interface. If you see here, from 192.168.23.2. Okay. So now let me go to the third one. If we go interface method, it is not necessary to provide the network ID. Yeah, it is not necessary. When you are not using interface method, that time you need to put the network ID, wildcard, mask, and area 0, like that. But if you do interface method, no need for that one. Yes. Okay. So what else we have here? We will go for the router R3, and we will check here also. Let me write here show IP route. If you see here, I have two routes here also. We are getting 1.1.1, and other route is 192.168.12.2. So this one we are learning, and we are learning this one in this router. And if you observe here, if we let me write here show IP OSPF. Show IP OSPF. We have a lot of information. Let me write show IP route. We wrote, right? In route, if you observe, we have here 110. As we discussed, administrative distance AD value is 110 in the OSPF. So if you see here, AD value is 110. If you see here, we have 12 as a cost. This is a cost. As we are saying cost, this is a cost. 12 we have here. If you see, if we want to go to this route 1.1.1 from the 23.1 here, so it is getting how much? 12, because the from here to here this will be 10 11 12. This the cost will be, I will show you cost also, no problem. If we go here like show IP OSPF interface, we are in the router 3, right? So I will write E is 2 by 3, E2 by 0. If you see here, cost is 10. This cost is 10. Why this cost is 10? This interface. Because of this interface E2 by 0, we have cost 10. This one. So when I am sending any packet, if anyone want to go from here to here, the cost will start counting from here. Let me write here. The cost will start counting from here. Example, if I want to send any packet or anything from here. Example, if I have any network here, they want to go. Example, this is a network. This one want to go to this one. So we will not count this anything. We will start counting here. So here we have the 10. Again here we have the 1, because fast Ethernet is 1, and here fast we have 1. So 10 plus 1 plus 1. So 10 plus 1 plus 1, that is equal to 12. So that's why we are getting here 12. First of all, see this one, this interface E2 by this one is having the cost 10. That's why I wrote 10. And this one is having the 1, and this one is having the 1. Let me show you this interface cost also. If you go here, if you write here show IP OSPF interface F0 by 0. If you see here, you have cost 1 here. Here 1. Again, if you check here 1, and here 10. That's why we are getting total cost is, if you check here total cost, what we get here. Let me check which one I am seeing from here, right? From going from here to here. So if you see here, we have 12. This one. Remember, we have 12 here. Why we have cost as 12? Because here we will have 10, and then again you need to remember, and anyhow I have table, later I will show you. Here the Ethernet will be, cost will be 10, fast Ethernet will be 1, loopback also 1. So like that it will be 10, 1 and 1. So that will be 12. To go from here to here is the cost is 12. Later if we have one more link like this with the fast Ethernet, then cost will change from 12 to 3, because this will be 1 and this will be 1 and this will be 1. So we will have 3. So this route will be removed from the routing table, and then we will have this route. Okay. Any confusion? No confusion, right? If you have any confusion, you can ask me, no problem. Or write in the comments. If it is okay also, you can write in the comments, that is okay. Or if you feel like facing any issue or unable to understand, you can write. And for how we are calculating the cost, someone asked me right before, how we are calculating 10 power 8, then the interface bandwidth of the interface. 10 power 8 means 1, 2, 3, 4, 5, 6, 7, 8. And here we have for the interface, if we go, we can check interface also. If we type here, example, if you see, we have here bandwidth. Let's see here. See here, hello timer, as we discussed, we have hello timer 10 minutes, dead timer 10 second and 40 second, this one. And the router ID, already the router taken this one as a loopback IP, this one as we discussed. And what we are looking here, we are looking the interface bandwidth. If you want to look the interface bandwidth, we can write like that also. So show interface E0, E2, let me write E2 by 0. If you write this one and go here, if you, this is the, not this one, which one, this one. If you see here, this one, this is a bandwidth. If you see this one, this is the bandwidth of the interface. We have 1, 2, 3, 4, and then we have 3, 0, 4, 5, 6, 7. So we will have this one 7, 0 here. If you divide 1 divided by, this is for Ethernet, we will write 7, 0, 1, 2, 3, 4, 5, 6, 7. So this one, and this is 7, so and this one will cut, we will have 10. That's why cos is 10 in the Ethernet. Okay, did you understand or any confusion? What I am saying, how we can calculate the bandwidth? Bandwidth in the OSPF is equal to 10 power 8 by that interface bandwidth. Interface bandwidth we can check. How we can check? We can write show IP interface, whatever interface you want to check. I want to check this interface E2 by 0. I wrote like this, so I found this is the bandwidth for that one. So this is a 1 2 3 4. I have 4 0 here, and then I have k means 3 0. So this is 3 and 4, total 7. So I wrote here 7 0 down, and up I have 8 0. Okay, 10 power 8 by 10 power 7 like this. So if we cancel, we have 10 here up. So that is a cos for Ethernet. Okay. In our live session, we are dealing this nodes and everything. Later I will show you some sample also. We are doing in Zoom, no issue. Okay. So this is okay, right? Actually now I have some work, so I will stop this live session. In next session, we are going to check some more detail in OSPF, like we can open the capture, we can capture the packet. Like example, if I want to capture, this is the router, you can go here, capture, and which interface you want to capture. I want to capture this interface E2 by 0, example E2 by 0. I will click this one, I will select the Wireshark, and I will click open. Then Wireshark will open here like this, and it will show. The Wireshark is nothing but packet analyzer. You can say packet analyzer, we can analyze the packet. And if you want to check any packet like OSPF, we can check the OSPF packet also here. Okay, let me check here. OSPF, it will take some time. Actually I need, here. If you see, we have hello packets. This guy 192.168.23.1 sending to this MAC address 224.0.0.0, and the other guy also sending to same MAC address. They are sending the hello packets. This packet, if you see here, hello like that. And if you want to open any packet, we can click here and we can go here in the hello header, OSPF header. If you see, this is a hello packet, and the router ID, this one is the router ID, and area, we are using the area 0. That's why here he wrote in the hexadecimal form 000 like that, and we are not using any authentication. That's why it is giving as a 0 here. If we use authentication, he will give some value here. And if you see hello timer, we can get here hello interval is 10 and dead interval is 40. All information you will get here. Okay, and if you want to check any MAC address, you can check MAC address, and if you want to check frame, you will check frame. And if we change any configuration, we will have another packet saying that this is changed like that. Okay, so I hope you enjoy this video and you like this video, you like this live session. I hope that one. So let's see in next live session, maybe tomorrow or day after tomorrow. Let's see, maybe we will continue this one, or already we cover a lot of thing in this. I hope. If anything is pending about the OSPF, anything, you can write in the comments, so we can do in the tomorrow live session. Okay, bandwidth calculation we discuss, and we see the hello packets. We already checked the dead interval and all this one. Let me check here. Let's stop this one. And what else? We look everything, right? So I think OSPF. If you want me to teach anything like any other topic or anything, you can write in the comments. So we will come online and we will give the live class, live session like this in YouTube. And if you are interested in live classes in Zoom, you can contact me also. We are having live session also in Zoom for CCNA. So if you want, we can do there also. But anyhow, if you have any doubts, you can write in the comments. And if you want me to cover any topic for the OSPF, you can write here. We have some more topics also we will see, or we will do any other routing protocol. I am going to add this video in the EVNG playlist. So if you have any question, write in the comments, or else I will stop the live session now. So tomorrow or day after tomorrow we will have another live session. Okay, thank you very much for seeing our video. Subscribe to our channel, like our video, and share with your friend who is interested in CCNA 200-301 as well as Python. Thank you. Bye.